Hi everybody, welcome to Unit 4 Video 1. If you do not have your Unit 4 notes out, please take them out now. Okay, so what we're going to do today is it says I can simplify quotients using the law of exponents. So whenever you have same base, so the base is 2, and you have an exponent in its division, you're subtracting these exponents. So it's numerator minus denominator. So here we have 6 minus 3, which is going to give us 2 to the third, which would simplify to 8. Okay, when you have coefficients like this, you want to divide them. So it's 4 divided by 2, which would reduce to 2. This a on the bottom has an implied coefficient of 1. So you have a to the third, so it means you have 3 a's on top, 1 a on the bottom. So when they reduce or you subtract, you're left with a squared. So that answers 2a squared. All right, if we take a look here at number 3, again, we want to start by dividing. 9 divided by 3 is going to leave us with 3. Here, when I simplify, I have x cubed on top, x squared on the bottom, so there's more on top. So 3 minus 2 is going to leave you with 1 on the top. On the y's, you have a y squared, y to the 5th, so that means there's 2 on the top, 5 on the bottom. So when you subtract those, you're left with 3 on the bottom because there's more y's on the bottom there, so on the denominator. So 3x over y cubed. Okay, I want you to pause the video and you try this one. Okay, so let's take a look at what we got. When we reduced, we got 2 ninths. Here, a to the third, a to the first in the denominator. So when you simplified, you're left with a squared in the numerator. With the b's, you have b to the first in the numerator, b to the fourth in the denominator. So when you simplify, you're left, or when you subtract them, reduce, you're left with a b to the third in the denominator. Okay, so now with these problems here, they're fractions. And so you have to remember your rules of fractions. You are allowed to cross simplify. So if you wanted to, you could cross simplify these d to the 5th and d squared, c to the 4th and c squared, and you could do that and then multiply straight across. But sometimes that can be a little messy. So I prefer to multiply straight across first, then reduce. So that looks like this. When I multiply straight across, on the top, I get 3c to the 4th. So 3c, my pen. Okay, sorry about that. So I have 3c to the 4th, d to the 5th. So then I have 2 times 6 is going to give me 12. And then I have c squared, d squared. All right, so when I reduce these, 3 over 12 is going to reduce to 1 over 4. Then c to the 4th on the numerator and c squared on the denominator, that's going to reduce to c squared in the numerator. And d to the 5th over d squared, that's going to leave me with d to the 3rd in the numerator. So my answer here, you could leave it like this if you wanted to, or you could write it as c squared d cubed over 4. Because remember that 1 in the coefficient is implied. All right, so when you have something like number 6, remember the squared is being applied to everything inside of the parentheses. So when you do that, 3 squared is going to give you 9. Here you're going to get r squared. Then on the denominator, you're going to have 5 squared, which is 25. And then x cubed raised to the squared. So remember, power to power is multiply. So you're going to get x to the 6th. In this case, there's nothing to reduce, so this is your answer. If you could reduce it, you would. All right, let's take a look at 7. So first I'm just going to bring over this first fraction here, p to the 3rd over q, and a multiplication sign. Then I need to do my order of operations. So I have to do my parentheses and my exponent. So I need to apply the exponent to everything inside of the parentheses, which is going to give me 3 squared, which is 9. Then I'm going to get q squared over p squared. So again, now that I have this, I could cross simplify and then multiply straight across, but I'm going to multiply straight across and then simplify at the end. So in the numerator, I have 9p cubed, p cubed, q squared over p squared q. And remember that q is to the first if you want to put that there. All right, so the 9, there's nothing left to simplify it with, so I'm going to leave it where it is. P to the 3rd and p squared, that's going to reduce. So you're left with p to the 1st on top. And q squared over q, that's when I reduce those, I'm just left with 1q, or so q to the 1st on the top. and there's nothing in the denominator, so that's your answer here. All right, so for number 8, remember you have to apply the squared to everything inside the parentheses, including this negative here. So why don't you pause the video and you try this one. Okay, so we're left with 1 over 2 RT. Remember 2/4, that's going to reduce to 1/2, and then r cubed on top, r to the 4th on the bottom, so there's more r's on the bottom. So when they simplify, you're left in the denominator with just r. Same thing with here. There's 2 t's on top, 3 in the denominator. So when you simplify, you're left with t in the denominator. But remember, there's 1 in the numerator, so it stays there. So it's 1 over 2 RT. Okay, so when you do number 9, remember you're distributing everything squared here, everything to the numerator, and the squared everything to the denominator. So when I do that, it's going to look like this. I'm going to get 4x to the 4th, y to the 6th, because remember, power to a power is to multiply. When I do the square on the bottom, 3 squared, so I'm going to get 9. Then I'm going to get x to the 6th, y squared. Okay, so now that I have this, I can reduce. There's nothing that I can take out of 4 and 9, so I'm just going to leave it as 4 over 9. And then x to the 4th, x to the 6th, I'm left with x squared in the denominator, y to the 6th over y squared, so I'm left with y to the 4th in the denominator. And so again, this right here, I'll make it a little clearer, that's a 4, remember, because nothing would reduce. So there's your answer. Okay, why don't you pause the video and you try number 10. Okay, so once we distributed our exponents to what was inside the parentheses, you were left with a squared, b to the 4th, c squared, over a to the 9th, b cubed, c to the 6th. So then when you simplified, you were left with b over a to the 7th, c to the 4th. Okay, when you have something like number 7 here, what you want to do is first you want to distribute this bottom because it's a parentheses exponent, and then we'll simplify the numerator and the denominator. So I'm just going to rewrite what I have in the numerator. A to the 2m, b to the 2m plus 1, over, remember, power to a power is to multiply. So I get a to the 2m, b to the 2m. And then you can do your rules. Remember, your rules are simplifying, or if you want to think of it in terms of subtraction, you're saying numerator minus the denominator. So it would look like this, a to the 2m minus 2m, and then you could say b to the 2m plus 1 minus 2m. And so you could reduce those. This becomes a to the 0. These two cancel, 2m minus 2m. So you're left with b to the 1st. And remember, a to the 0 is same as saying 1 times b here. So your answer is just b to the 1st or b. But again, you also could have just simplified here, up and down, but this is the algebra for it. All right, so for number 8, you want to simplify the numerator first because they are like terms. Remember, same base multiplication means you add the exponents. So here we have n and n. So that's going to give us t to the 2n. You have 1 and negative 1. So that means these two are going to cancel out. In the denominator, you had t to the n. So then again, you could just go ahead and reduce. But if you wanted to see what it would look like algebraically, numerator minus denominator, so it's 2n minus n, which leaves you with 2n minus 1n is just n, so you're left with t to the n. All right, let's go ahead and go to the next page. So our next page here, it's saying I can simplify expressions involving the exponent 0 and negative integral exponents. All right, so here are our rules. Our general rules for your exponents. If n is a positive integer and a doesn't equal 0, then it follows these rules. A to the 0 equals 1. A to the negative n, to make it a positive, if it has a negative exponent, you say 1 over a to the n, and 0 to the 0 is undefined. All right, so let's take a look at what that looks like. Or what these rules look like. So here, we're saying x squared over x to the 3rd, which we just did and we reduced. And we already know this is going to be 1 over x. But according to these rules here, if we do it this way, it's the same as saying x 2 minus 3. So it's always numerator minus denominator. So 2 minus 3 is going to give you x to the negative 1, which gives us 1 over x. But it's the same thing if you were just to reduce them. All right, here, again, following that same rule here, we have y to the 5th minus 3, because again, it's numerator minus the denominator, which is going to leave us with y squared. And here, remember, this we already know is going to reduce to 1 because it's part over whole when you do fractions, and this is all the parts over the whole, so it would equal 1. But if we do it mathematically, it's going to look like numerator minus the denominator. So x to the 3 minus 3 is going to be x to the 0, which equals 1. All right. Okay, so for the next part, it says, express the following without negative exponents. So we only want positive exponents here. So it means we need to make this a positive exponent, which is going to turn into 1 over 2 squared. So we have 1 over 2 squared times 3 over 2. Well, remember, this 3 over 2, since you're multiplying it, there's an invisible 1 here. So you could just multiply straight across, which would give you 3 squared over 2 squared. And then we can go ahead and do that. So 3 squared is going to give you 9. 2 squared is going to give you 4. So you're left with 9/4. All right, when you're doing something like this, in order to make this negative exponent positive, again, like here, we're going to flip it. It's not going to do anything to the exponent on the inside. It only takes care of the exponent on the outside. So we're going to get 1 over negative 5 times 4 to the negative 1 squared. Again, it's only taking care of this outside one. So then when we distribute here, you have 1 over, so this you got to distribute here, negative 5 squared times 4 to the negative 2. But since this 4 to the negative 2 is in the denominator, to make it positive, it needs to go back to the numerator. So we're kind of going back and forth here. So now this becomes 4 squared over negative 5 squared. So if we simplify that, we're going to get 16 over 25. All right. So for number 6, you want to simplify and make everything positive exponents before you fully simplify. So here, 2 to the 0, I know is going to turn into 1. This 2 on the bottom, it already has an implied exponent of 1, 2 to the first, which is positive, so you're going to leave it on the denominator. This x to the negative 3, it's in the numerator. To make it positive, you're going to move it to the bottom and get x to the third. This x to the negative 1, to make it positive exponent, you bring it to the top. So this is x to the first. This y, it already has an implied exponent of 1, which is positive, so it stays in the numerator. This x to the negative 2 in the denominator, to make it positive, it goes to the top, so you bring it up to the numerator, so y squared. So then, now we simplify it. We already know this is 1/2, so I'm going to leave the 2 in the bottom, and there's already implied 1 up here, but you can put it if you want. So here when you reduce, you get x to the first over x to the third. When you cancel those, you're left with more on the bottom, so you have x squared. Here you have y, same base multiplication, so you're going to add the exponents. So 1 plus 2 gives you 3, y to the third. All right. So with number 7, you need to be really careful because the common error is people want to apply the negative 2 to the 3, but it's not. The exponent of negative 2 only applies to the x. This 3 already has its invisible implied exponent of 1. So since it's positive, it's going to stay there. It already has a positive exponent. This x to the negative 2, to make it positive, since it's in the numerator, it would have to go to the denominator. So that becomes x squared in the denominator. This y to the negative 1 in the denominator, to become positive, moves back to the numerator. So this becomes y to the first here. There's nothing to reduce, so this whole thing is your answer. All right, so again, for this one, we want to start by flipping it, but when you do that, it only takes care of the outside exponent, not the inside. So this becomes 1 over the quantity 2x to the negative 2 y squared, all of it squared. All right, so now when I distribute, I have 1 over 2 squared is going to give me 4, x to the negative 4, and y to the 4th. So that means to make this x to the negative 4 positive, it needs to go back to the numerator since it's in the denominator. So I'm going to move it back to the top. So it's x to the 4th. And then on the denominator, I have 4y to the 4th. All right, so for this one, I'm just going to distribute right away because I already can tell a negative and a negative is going to make it a positive. So I'm going to distribute my exponent. So I'm going to get x negative 2 times negative 2 is going to give me a positive 4. In the denominator, I'm going to get, remember there's an implied 1 here, so 2 times, or 1 times negative 2 is going to give you y to the negative 2. So since this is in the denominator, to make it positive, I have to move it to the numerator. So I'm left with x to the 4th y squared. Okay, number 10. So you want to distribute that square there. So you're going to get that negative square. So you get 2 to the negative 2. And then here, this is negative 1 times negative 2. So x squared over. This 2 already has an exponent of a 1. This negative 2 here does not apply. So you're just bringing the 2 down. Now you're going to multiply these. So negative 1 times negative 2 is going to give you y squared. Okay, so I need to bring this 2 to the negative 2, make it a positive exponent. The x squared is already positive, so it stays. So when I bring this down, it's going to give me 2 squared. You already have this other 2 in the denominator, so bring that over, 2, and then y squared. All right, so the last thing left to do is to simplify. 2 squared is 4, times 2 is 8. So your final answer is x squared over 8y squared. Okay, let's try it. I want you to pause the video and try number 11. Okay, so when we simplified, then we should be left with a to the 4th, b to the 3rd. All right, why don't you go ahead and pause the video and try 12. Okay, so when we distributed, we got x to the negative 4 over y squared, and then y to the 4th over x to the negative 2. So what I did first is made all those exponents positive. Then I multiplied straight across, which gave me this. And then once I had it as a single fraction, I simplified. So my final answer was y squared over x squared. All right, so for number 13, again, let's go ahead and I'm going to flip these ones first. So I'm going to get s squared over r. So then times, when I distribute the negative here, or the negative exponent, I'm going to be left with r to the 1st over s to the negative 2. So again, I'm going to get s squared over r times, I'm going to make this positive, so s squared over r, or s squared times r over 1. So then when I multiply straight across here, I get s to the 4th r over r. These would cancel out, the r on top and the r on the bottom. So then you're just left with s to the 4th. S to the 4th. Okay, so for our next one here, this is addition. So remember, addition of fractions, they have to have a common denominator. So the first thing I want to do with this term is make the y to the negative 6 positive. So I'm going to move the y to the denominator. So this is 4x cubed over y to the 6th. I'm going to bring down the plus sign. And then here, again, I'm going to distribute the exponent. So I'm going to get x to the 3rd over y, or times y to the negative 6th. And so then to make this exponent positive, I need to bring it to the denominator. So I'm going to rewrite this first term. So 4x to the 3rd over y to the 6th plus x to the 3rd over y to the 6th. So then now they have a common denominator of y to the 6th. So that means I can just add the numerators. So 4x cubed plus 1x cubed gives me 5x cubed. And remember, when you add or subtract fractions, the denominator just stays. So it's just y to the 6th. All right, so let's go ahead and try this one. So again, distribute your square here. So u to the 4th over v squared. Bring down your plus sign. So then I'm going to flip this here. So I'm going to get 1 over negative u to the negative 2v, all of that squared. So I'm going to bring just this down again, u to the 4th over v squared. So I get 1 over, I'm going to distribute the square to everything inside here. That's going to give me a positive, so this right here, so 2 to the negative, that's positive, and then I have u to the negative 4th v squared. So it means I need to move this u to the -4 back up top. So I get u to the 4th v squared plus u to the 4th v squared. So now they have a common denominator, so I can just add the numerators. So 1u to the 4th plus 1u to the 4th is 2u to the 4th over v squared. So that's your answer there. All right, thank you for watching today's video.